Today our topic is parallelograms. So our learning target, how can I identify parallelograms using side and angle measures? So first off, we just need that definition of a parallelogram. So by definition, a parallelogram is a quadrilateral. So that's four sides with both pairs of opposite sides parallel. So both pairs means both opposite sides are parallel. And remember, we marked parallel with these little triangles here. So both pairs of opposite sides are parallel. That's the definition. Now there are some other qualities of parallelograms, and that's where these theorems come into play. So on your resource sheet, the first two are Theorem 8.3 and Theorem 8.4. Theorem 8.3 states if a quadrilateral is a parallelogram, then its opposite sides are congruent. So that's a piece you might want to highlight. Opposite sides are congruent. So it could be like these two sides are 5 and these two sides would be 3. So they're the same length. And then Theorem 8.4 states if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles, so this could be like 110 and then these would be 70. All right. So example 1, we're going to use Theorem 8.3 and 8.4. Find the values of x and y. Well, we start with x. We can use the fact that opposite sides are congruent from Theorem 8.3 and set x plus 4 equal to 12 minus 4 on both sides, and x equals 8. To find y, we can use the fact that opposite angles are congruent, so we can set y equal to 65, and that solves it. Y is equal to 65 degrees. All right, the next set of theorems, so back to your resource page, the last two on the front side are Theorems 8.5 and 8.6. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive angles means the angles right next to each other, and supplementary means they sum to 180. So these two right here would sum to 180, these two right here would sum to 180, these two would sum to 180, and those two would sum to 180. So each angle pair that's right next to each other sum to 180. All right, so and then Theorem 8.6, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So diagonals would go across, and bisect mean they cut evenly in half, so both pairs are congruent. So in example 2, we want to use these two theorems to find the indicated measure in parallelogram JKLM. So NM, if we look, we want this piece right here. So it's a diagonal, which means it's bisected. So this side is 2, which means this side will also be 2. So NM is 2. Then we want KM, so we want from K to M, so we want the whole piece. Well, that's just adding the two pieces together. 2 plus 2 gives us 4. Measure of angle JML. So JML, we want this angle right here. So we know this side is 110, which means that these two angles are going to sum to 180. So we can say that the measure of angle JML plus 110 equals 180 minus 110 on both sides, and we get the measure of angle JML is equal to 70 degrees. So we can put that right up there. And then the last piece, we want the measure of KML. So KML would be this piece right here. Well, we know this whole angle is 70. We know this half is 30, so this other piece right here is going to have to be 40 degrees. All right, go ahead and flip your paper over to the back, and while you do that, you can enjoy some fun memes. Proving a quadrilateral is a parallelogram. So on the back of your resource sheet, we have theorems that prove that a quadrilateral is a parallelogram. And it's just taking the theorems on the front page and flipping them around. So instead of saying if you have a parallelogram, then both opposite sides are congruent, we're saying if you know that both pairs of opposite sides of a quadrilateral are congruent, then we know it's a parallelogram. So it's just taking it backwards. So if we know certain information, we can state for a fact that a quadrilateral is a parallelogram. And then theorem 8.8, if you know both pairs of opposite angles in a quadrilateral are congruent, then that quadrilateral is a parallelogram. And then theorem 8.9 and 8.10 follow suit. If one pair of opposite sides of a quadrilateral are congruent and parallel, then we can state that the quadrilateral is a parallelogram. And then if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So those are the 4 different ways that we can show that a quadrilateral is a parallelogram. So on the back of your notes, we have example 3 for what values of x is quadrilateral CDEF a parallelogram. So we know that this pair of diagonals is bisected, so then we want this diagonal to also be bisected, which means that 5x minus 8 needs to be equal to 3x. So we solve this for x, subtract 5x on both sides. We have negative 8 equals negative 2x. Divide both sides by negative 2, and we get x equals 4. Example 4, what theorem can you use to show that the quadrilateral is a parallelogram? So since we are proving that it is a parallelogram, we're using the theorems on the back side of our resource page. So for the first one, what do we know? Well, we know that these two sides are parallel by these little triangles here. And then we also know that they're congruent because they have the same measure of 30 meters, which means we can use theorem 8.9 to show that it is a parallelogram. For number 3 here, they're weirdly numbered, we have both pairs of opposite sides are congruent. So that is theorem 8.7. And then for the last one, we show that opposite angles are congruent. We're working with both pairs of opposite angles, which means we are using theorem 8.8. All right, last example. At the bottom of your resource sheet, it's just a shortened little diagram of ways to prove a quadrilateral is a parallelogram. So this is kind of a nice little diagram. So you can show that both pairs of opposite sides are parallel. And if we're looking at parallel, that means they have the same slope, or we have these little markings given. Then we can show both pairs of opposite sides are congruent. So opposite sides congruent. They could have the same measure or the congruent markings. Show both pairs of opposite angles are congruent. So we got the angles being congruent, and then show one pair of opposite sides are congruent and parallel. So this is when you just focus on one pair. So we have congruent and parallel. And then the last one is those diagonals, that they bisect each other. So certain pieces will be helpful in certain diagrams. So if we look at our example 5, show that the quadrilateral ABCD is a parallelogram. So if we look, we could use the definition. We could show that both pairs of opposite sides are parallel because we're working with a graph. We could find the slopes of all the sides using rise over run. And we could show that opposite sides are parallel. We could show that opposite sides are congruent by using our distance formula. We could show that both pairs of opposite angles are congruent. Actually, no, we could not because we don't have any information on angles. So that's the one that we couldn't use in this case. We couldn't use theorem 8.8 because we have no information on the angles. We could show one pair of opposite sides are congruent and parallel. We would just focus on one pair of sides. We could focus on this pair right here. We'd use the slope and the distance formula in that one. Or we could show that the diagonals bisect each other. We could draw diagonals on here and then find the distance, show that they bisect each other. That one would be more complicated. So that one I would not suggest using, but the other three would all be good options. However, I think that the best option is using the definition because finding the slopes of these lines is going to be a lot easier than using this distance formula. So let's use the definition. So all we have to do is show that opposite sides are parallel. So let's start with this pair of red sides. So we have AB, find that slope. We go up to 1, 2, 3, 4, 5 over 5. So slope of AB equals 2 over 5. And then slope of CD is also 2 over 5. So that's one pair. And then we need the other pair. So AD and BC. So slope of AD, we're going down 3 over 3, which would have a negative 3 over 3 slope, which equals negative 1. And then for BC, we're going down 3 over 3. So that also has a slope of negative 3 over 3, which equals negative 1. So by the definition, since both pairs of opposite sides are parallel, have the same slope, then we can state that this quadrilateral is a parallelogram. That's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.